We're going to look at two examples that involve limits with square roots. So looking at this first limit, I want you to take a second, go ahead and put this on pause and see if you can evaluate the limit based on what we've done in class. Okay, so you'll notice right away that if you plug in 4, if we look in the denominator, my denominator is going to be 0. So this function that I'm taking the limit of doesn't exist when x is 4. But the limit may still exist as x approaches 4. What happens when you plug in 4 into the numerator? We're also going to get 0. So we get 0 over 0, which is an indeterminate form, which means we need to try something else to evaluate this limit. So one of the next things we usually try is to see if we can factor or simplify, and I can't see any nice way of factoring this. So the trick when you have a square root is to see if rationalizing this helps. And rationalizing means we're going to try to get rid of the square root in the numerator. So rationalizing is going to make use of the fact that the quantity a minus b times the quantity a plus b is equal to a squared minus b squared. How does that help us? Well, notice if either a or b had a square root in them, or were a square root, then over here when you square a square root, the square root goes away. Okay, so we're going to use that idea to rationalize the numerator. So let me rewrite the limit. And I'm hoping you'll see why I've been using these different colors. The colors is to help us see the analogy. And that in order to rationalize, I need to multiply by the conjugate. So how do I find the conjugate? You look and see, since the numerator has the square root in it, we're going to take the same two terms that we have in the numerator. So I'm still going to take the x, and I'm going to take the square root of 3x plus 4. So you leave the terms exactly as they are. The only thing that changes is instead of subtracting, as we have subtraction here, you're going to change it to an addition. Okay, now I can't just go around multiplying expressions by anything I want without changing the value of the expression. So I don't want to change the value or change the thing I'm taking. Oops. Okay, we're back. I don't want to change the value of what we're taking the limit of, or the function we're taking the limit of. So if I multiply the numerator by something, I'm going to have to also multiply the denominator by the same thing so that I don't change the original function. Okay, so remember, when you multiply the numerator and denominator by the same thing, it's the equivalent of multiplying by 1. Alright, so how does that help us? So now, in my numerator, I'm now going to get x squared minus, and then I'm going to be squaring the square root of 3x plus 4, which means that square root's going to go away. Be really careful to include parentheses. So you're going to have x squared minus this now. And the trick whenever you do this multiplying by a conjugate is you don't need to expand out the other part. So I'm going to leave the denominator factored. You can leave it like this. Alright, so now my numerator will become x squared minus 3x minus 4. I'm leaving the denominator factored. Alright, now we treat this, say, okay, now I've rewritten this limit now. How can we evaluate this? So let's go back to plan A. Try plugging in 4. We plug in 4, we're going to get 0 over 0 again. But now this looks like we could factor. So notice you can factor the numerator. And I'm pretty close to being able to cancel. I have an x minus 4 factor and a 4 minus x. So you know what we need to rewrite. Let's rewrite that 4 minus x in the denominator. Let's pull out a negative. Alright, and now when we've written it this way, we can cancel this x minus 4 factor in the numerator and the denominator. The numerator will be left with x plus 1. And we'll need to move to a new page, but the denominator's just going to have the negative and then the same factor that we've had. And now the great news, if you go back to substitution, we're actually going to be able to evaluate this limit. So when I plug in 4 in the numerator, I'm going to get 5. Into the denominator, I'm going to get 8, a negative 8. Negative 8, so let's pull the negative out front. So we're going to end up with a negative 5/8 for this limit. So that's the main strategy. Okay, so based on that, now let's do a little twist. So now let's look at this limit. So notice now I have two variables. I have an x and an h. I'm just taking the limit as h goes to 0. Okay, so at the end of the day, I'm still going to have an x left in my final answer. The only thing that's going to 0 is h. Alright, so let's try this one again. So go ahead and put it on pause, and based on what we just did, see if you can evaluate this one. Okay, if you try direct substitution, if you plug in 0 for h, you're going to get 0 over 0 again. Alright, so we have a square root. So we're going to try this multiplying by the conjugate trick. One of the hardest things to remember when you're multiplying by the conjugate is just to keep track of all your parentheses. So put your original limit, your original numerator in parentheses. Now let's figure out what our conjugate is. So remember, the rule is you're going to take the terms exactly as they are. These are not going to change at all. So I'm going to still have the square root of x plus h, and I'm still going to have square root of x over here. Okay, the only thing that's going to change is instead of subtracting them, I'm now going to add them. And if I've done that in the numerator, I've got to do the same thing to the denominator, so I don't change the value of the function that I'm finding the limit of. Okay, so this is the equivalent of just multiplying my original thing by 1. Haven't changed anything. And now we're using this so that we can get rid of those square roots in the numerator. So our numerator is now just going to become the square root of x plus h squared. So that's just going to leave me x plus h. Minus the square root of x squared. So that's just going to leave me x. Okay, we can leave my denominator factored. So I'm going to leave the h here, and then I'm going to leave this piece all factored. Alright, then we're just going to do some simplification in the numerator and see if we can do some cancellation. So notice in the numerator, I'm just going to be left with h. Here's my denominator, and mission accomplished. I'm now able to cancel some things in the numerator and denominator. Let's rewrite my limit. Okay, now I've rewritten this in a form such that when I plug in h, I'm now going to actually be able to evaluate this limit. So when I let h be 0, my numerator is still going to be 1. My denominator, I'm going to get the square root of x plus the square root of x. So I can combine those. This gives me 1 over 2 square root of x. And that is my final answer for this limit. As you can see, it still involves x, which is fine. So we were just taking the limit as h went to 0. And that's it.